Hey, welcome back. This is lesson 2 in Unit 4 of Calculus AB, our AP Calculus course. We'll be looking at a little bit more implicit differentiation in this lesson, looking at some more applications for vertical tangent lines, horizontal tangent lines, equations of tangent lines, things like that. So let's get right to it. All right, example 2.1 says find the equations of all the tangent lines to the curve xy plus y squared minus x squared equals 1, where the point of tangency is 1 comma k for some k value. So we know that tangent lines, we need to get for the equation of a tangent line, we need the slope, which is dy over dx. So let's do that. Let's get the derivative here. That would be derivative of this here. This term is going to be the product rule, so I need the first derivative of the first times the second, so that's y, plus the first times derivative of the second, and the derivative of y is dy over dx. All right, then for y squared, I use the power rule, so it's 2y to the first, and the chain rule says times dy dx. Then minus 2x, and then the derivative of 1 is 0. All right, so we just simply get all the terms that have a dy dx in it on one side. And I'll move the terms that don't over to the other, factor out a dy dx. And I get that. And so lastly, I have dy over dx is equal to 2x minus y over x plus 2y. We want to find the equation where the point of tangency is 1 comma k. So let's find the k value. We know the x value is 1. Let's plug it in the original equation here. So I have 1 plus times y is y, plus y squared minus 1 equals 1. This is a polynomial, so to solve it, I need to get it equal to 0. And this one is factorable, so I'm going to say y plus 2 and y minus 1. So we get y equals negative 2 and y equals a positive 1. So we have two different points where the x value is 1. Let's find the dy dx at each one of them. So dy dx at the point, let's see, we're doing 1, right? So 1 comma negative 2. What would that be? Well, 1 times 2 minus a negative 2 all over 1 plus 2 times a negative 2. That is 2 minus a negative, well, hold on. 2 minus a negative 2 is plus 2, so 4. And that is 1 minus 4, right, is a negative 3. Okay, so I can write that equation as y plus 2 equals a negative 4/3 times x minus 1. All right, let's try the next one. We need to do dy dx when we have x equals 1 and y equals negative 2. So dy dx, I'm sorry, when x equals 1 and y is equal to 1. So we have 2 times 1 minus 1 over 1 plus 2. So that would be 2 minus 1 is 1/3. So this equation would be y minus 1 equals 1/3 times x minus 1. Let's pull up a graph. So I'm going to just type in the equation right quick here on Desmos. So we have xy plus y squared minus, where's that u come from? Y squared minus x squared equals 1. All right, so we have this kind of angled hyperbola looking thing. And we talked about x equaling 1, so it looks like, yeah, we have a line there. Let's graph the first one was y minus 1, y plus 2 equals a negative 4/3 times x minus 1. That's one tangency. And the other one, if my memory holds, was y minus 1 equals 1/3 times x minus 1. I think that was right? Yeah. So those look pretty tangent, don't they? So we were able to do it. Okay, so now we're going to find the x-coordinates of any points where the curve has a horizontal tangent line. So horizontal tangent line occurs when we have the numerator is equal to 0. So let's solve 2x minus y equal to 0. All right, I can solve that, and I get that 2x is equal to y. All right, great. Let's plug it in for y now in the original equation. So I have 2x for y, right, times an x. Forgot my x. And then y squared would be 2x squared, make sure you use parentheses, minus x squared equals 1. So this becomes 2x squared plus 4. 2 squared is 4, so 4x squared minus x squared equals 1. So that's a 5x squared equals 1, so x squared equals plus or minus the square root. When I divide by 5, 1/5. And we should test to make sure that that value actually does. You could test to make sure that that value actually exists, but we've actually already plugged it into the original equation. We know that when x equals this, y is equal to twice it. That would not give me a 0 in the denominator, so I'm very confident that both of these values definitely are places where the graph is a horizontal tangent line. So when x is equal to the square root of 1/5, and when x is equal to negative the square root of 1/5. So let's go ahead and let's check that out. We just had it in decimals, so we can do it. The square root of 1/5 is about 0.447, and there you have it, plus and minus. Okay. All right. Turns out the y coordinate there is kind of hairy to get. Big nasty radicals within radicals, so we'll just skip that part. But the x coordinate was not too bad, right? Okay. So let's do this next one. Let's find all the points where this curve has a horizontal tangent line. So to find it has a horizontal tangent line, I need to set the derivative equal to 0, right? Which means the numerator has to equal 0. So I'll take the derivative. I have to use the product rule. Derivative of the first is 1 times the second, plus the first times derivative of the second, which is 2y to the first dy dx. And I just put that 2 in front. Minus, okay, I still got to do the product rule. I'm actually going to think of this as plus a negative x cubed, so the negative comes along with it. So derivative of the first would be a negative 3x squared y plus derivative of the, which will be a plus the first times derivative of the second. So it's still got a negative. You could also put that negative outside in parentheses, but just keep in mind each one of them gets it. So the first time I took the derivative of negative x cubed. The second time I just took the negative x cubed, took the derivative of y. And the derivative of 6 is 0. All right, I'm going to get all the terms that have a dy dx on one side. And I'll put the other terms over here. 3x squared y minus y squared. So I factor out a dy dx and divide by it. And hopefully you're okay with me kind of doing that all at once. 2xy minus x cubed. All the points where we have a horizontal tangent line. Well, that's when the numerator would equal 0. So let's solve that. 3x squared y minus y squared is equal to 0. So I will factor out a y, and I get 3x squared minus y equals 0. So clearly when y is equal to 0, we'll have a horizontal tangent line. Well, what about with the x's? Well, I have to solve this equal to 0, so I have 3x squared equals y. I'm actually going to move this down just a hair. Move that down to, whoops. And I can always erase later if I need to. Make more room. All right, so let's go back. Let's see here. What do we have here? We have y equals 0. Well, we got to find the points. Let's plug in a 0 for y. Okay, let's do that. So x times 0 squared minus x cubed times 0 equals 6. Well, that gives me 0 equals 6. So it turns out this is not giving me any points, because apparently y never equals 0 in this curve, right? That's apparently not the case. So let's try this next one. We're going to let y equal 3x squared. So I have x times 3x squared, and then that's squared. And then I have negative x cubed times, again, 3x squared equals 6. All right, well, this becomes 9x to the 4th times x. So that's 9x to the 5th. And then this becomes minus 3, and then add the powers, x cubed, x squared, x to the 5th equals 6. So that's 6x to the 5th equals 6, right? Which means x to the 5th equals 1. So I get x, the 5th root of 1 is 1. So x equals 1. Well, if x equals 1 and y is equal to 3 times 1 squared, then y must equal 3. So 3 comma 1 appears to be the only value where this has a horizontal tangent line. Let's check it out. xy squared minus x cubed y. One comma 3. That's it. That's our guy that has the horizontal tangent line. All right. Well, what about a vertical tangent line? If you don't mind, I'm going to go ahead and just remove all this work. So pause the video if you need to see it again. But I do need that derivative. So I'm going to save that derivative. I'll put it over here, right? Because that's the same equation, isn't it? I'm just going to clear this out and then move this up. All right, and then I'll take that guy. I need that. All right, let's take a look. When does it have a vertical tangent line? It has a vertical tangent line when the denominator is equal to 0. So when 2xy minus x cubed equals 0. I'm going to factor out an x, and I get 2y minus x squared equals 0. So apparently when x equals 0 is one of them. And then the other one would be when 2y equals x squared. So y equals x squared over 2. Well, let's start with the x equals 0. Well, if it's at x equals 0, we have y squared times 0 minus 0 times y equals 6. That's the same problem we had before. So that's apparently not going to be a value. And you can see x equals 0 is not on this curve either. X equals 0 nor y equals 0. So let's try the other one. We're going to replace y with x squared over 2. So I have x times x squared over 2 squared minus x cubed times x squared over 2 equals 6. All right, this becomes x times x to the 4th. Power to power, you multiply, and then 2 squared is 4. So when I raise a power to a higher power, I multiply the exponents. Here, an add, you get x to the 5th over 2 equals 6. So this becomes x to the 5th over 4 minus x to the 5th over 2 equals 6. I'm going to multiply both sides by 4. So multiplying each term by 4 gives me x to the 5th minus 2x to the 5th, because 4 divided by 2 is 2. And then that equals 24. So that's negative x to the 5th equals 24. And so x to the 5th equals negative 24. Take the 5th root of each side, and I get negative 24 to the 1/5. And remember, you can take an odd root of a negative number. That is okay. So if that's the x value, what's the y value? Well, the y value then must be negative 24 to the 2/5 over 2. So we have a vertical tangent line at the point negative 24 to the 1/5, comma, negative 24 to the 2/5 over 2. And I think we can see that as well. That's going to be right over here. So we can actually type that in. We can say, what was the x coordinate? Negative 24 to the 1/5. And then we had negative 24 to the 2/5. And was it like over 2 or something like that? Yeah, and then then that was divided by 2. Okay, looks like we got it, right? And so the equation for that tangent line, if we were wondering, would be just x equals the x coordinate. And so you can see that tangent line there. Pretty neat, huh? Okay, so let's do another one. Find the second derivative, which is called d2y dx squared. Let's talk about why that's the notation, first of all. So the derivative with respect to x of dx over dy. Well, that's d times dx. I know it's not technically multiplication, but that's where the symbol comes from so that it looks like it. Well, if you were doing this multiplication, you would think d times d is d squared times x. Okay. Doing that backwards, sorry. Getting a little ahead of myself there. We're doing the dy over dx, right? So the d dx of dy over dx. So the first derivative is dy over dx. We're going to take the d dx again of that. So d times d would be d squared y, and then dx times dx, well, you could call it d squared x squared, but we just call it dx squared. But we don't need the parentheses, so we just say dx squared, because dx is actually one variable. All right, so let's do that. We'll take the derivative. This becomes 2y dy dx plus, okay, I got to use the product rule. Derivative of the first times the second plus the first times derivative of the second equals 0. Going to solve for dy dx, and if you allow me to just kind of do that quickly, it's going to end up being negative y over 2y plus x. Now I got to find d2y dx squared. So d2y dx squared actually requires us to use the quotient rule. So low d high minus high, so it'll become a plus y, times d low, so it's 2 dy dx plus 1, because the derivative of x is 1, all over low low. But this is not in terms of y and x. So what we need to do is we actually need to replace the dy dx with what dy dx is. So let me move that down again and do that. So we're going to say it is that d2y dx squared is 2y plus x times a negative dy dx. So instead of actually being a positive y over 2y plus x. Then that one becomes a y plus 2x plus 1 all over 2y plus x squared. Now in this situation, you can actually see on the left, these 2y plus x's would actually reduce out. You're oftentimes going to get this stacked fraction. So if you wanted to get rid of it, you just multiply the top and bottom by 2y plus x. To each term, and so the 2y plus x goes away there, it would go away there, and it would get one there, and then that would become a cubed. But I'm not going to do that right now. You can certainly practice if you like. Okay, go ahead and find the second derivative on your own, please, and then we'll go over that. All right, hopefully you gave this your best effort. So let's see. The first derivative would be derivative of 1 is 0. Then we got to use the product rule. So negative y minus x dy dx equals 1 minus dy dx. So let's see here. I'm going to have dy over dx minus x dy dx equals 1 plus y. Factor out a dy dx. Be careful here. You get a 1 minus x. So dy over dx is equal to 1 plus y over 1 minus x. Take the second derivative, that's d2y dx squared, low, d high, minus high, d low, all over low low. All right, I got 1 dy dx to replace, so I have 1 minus x times 1 plus y over 1 minus x. And then that becomes a plus 1 plus y all over 1 minus x squared. So this one actually reduces really easily. The 1 minus x's will reduce out, and you end up with 2 plus 2y over 1 minus x squared. But I didn't ask you to simplify. I did ask you to replace the dy dx, though. All right, let's practice on this one. Consider this curve y cubed plus y squared minus 5y minus x squared equals negative 4. First, cool graph, right? Let's find the dy dx. So that's a 3 y squared dy dx plus 2y dy dx minus 5 dy dx minus 2x equals 0. All right, we'll solve for dy dx. So factor out dy dx, and you'll get, well, actually, we need to move the 2x over first, right? So move the 2x over, and then you'll have 3y squared plus 2y minus 5 is equal to 2x. So then dy dx is equal to 2x over 3y squared plus 2y minus 5. We're going to write the equation for the tangent line at 1, negative 3. So that's going to be something kind of flattish. But we can do that, right? So we'll just find dy dx at 1, negative 3. So this becomes 2 times 1 over 3 times a negative 3 squared plus 2 times a negative 3 minus 5. So that's 2 over 9 times 3 is 27, minus 6 minus 5. So this is 2 over 21 minus 5 is, what is that, 16? So 2/16, we could call that 1/8. So the equation of the tangent line is y plus 3 equals 1/8 times x minus 1. Which certainly looks reasonable. It's definitely a very flat line, 1/8, very flat slope. All right, find the coordinates of the points on the curve where the tangent line is vertical. Well, that means when the denominator is 0. Well, that is going to be when 3y squared plus 2y minus 5 equals 0. And this is factorable because there's numbers that 3 times 5 is a negative 15. And 5 and 3 multiplied to negative 15 and subtracted 2. So this definitely is factorable. So I want, let's see here, let's do that. And we'll do 5 times 1y. So that'd be a 5y. And that'd be a minus 3y equals a plus 2y. So 3y squared minus 3y plus 5y is 2y minus 5. So you get y equals negative 5/3 and y equals 1. We want to, those are the y coordinates. Let's get the x coordinates. Well, the x coordinates, we got to plug it back into the original, right? So let me go and grab that right quick. All right, so I'm going to say, I'll do the 1 first. And then 1 squared minus 5 times 1 minus x squared equals negative 4. So that is 1 plus 1 minus 5 minus x squared equals negative 4. So that's negative 3 minus x squared equals negative 4. So is that 1 equals x squared? So x is equal to plus or minus 1. So it looks like 1 comma negative 1 and 1 comma positive 1. And I think we can see that there's vertical tangent lines there. Let's do the other one. So this would be a negative 5/3 cubed plus a negative 5/3 squared minus 5 times a negative 5/3 minus x squared equals negative 4. Well, the math, of course, is going to be a lot yuckier here. So that's just going to be the way it is. As a negative 125 over 27 plus 25 over 9 plus 25 over 3 minus x squared equals negative 4. This becomes 75 over 27, and this becomes 9 times 25 is 225 over 27. So let's see here. This is negative 50. So 175 over 27. So we have a negative 4. It's going to end up being a minus 175 over 27. And x is going to be plus or minus the square root of that after we negate it, right? I know I'm rushing through this, but, you know, the number doesn't really matter that much, right? because that was a negative x squared. So hold on, I have to. So it's actually going to become a plus. So we could do that calculation right quick if you really wanted to, but I'm going to leave that to you and just leave it like that. So those are the coordinates 1, -1, 1, 1, and then we have -5/3 in this monstrosity and -5/3 in negative that monstrosity. Okay. So I think I'm just checking my notes here. That's all I have for today. Take care, and I'll see you in the next lesson.